Hi everyone, Professor Bob Young back at you here. In this instructional video, we're going to talk about what is called in trigonometry the product to sum and the sum to product formulas. So that's going to be our objectives, is to use these formulas here. So you can see why they're called this. On the left side here, we have the product of two trigonometric creatures with angles involved, sine of some angle u times the sine of some angle v, and you can take this product multiplication and rewrite it as addition or subtraction. Now remember, subtraction is also called sum. You could say that's plus a negative and so forth. So that's why they call all of these, whether they have plus or minuses, the sum here. And notice we'll put some angles in here and show you this absolutely makes sense if you want to later. And then the sum to product, you have sums and differences. Again, differences can be written as sums, and we're going to take these and rewrite them as products. So again, in later courses, it will be advantageous for you to integrate, differentiate, use higher level applications to write these formulas more basic and simple and so forth. So let us go ahead and begin here. Now the first example says express the product as a sum or difference. So they give us the sine of 5x times the sine of angle 2x here, and we're going to take this formula and we're going to rewrite this product as a sum right now. All right, so for alpha, we're going to substitute in 5x here, and for beta, we're going to substitute in 2x. So these are some of the easier formulas here that we've dealt with in this chapter with double angles, half angles, and so forth, and sum and difference formulas. So we'll say this is going to equal the product 1/2 times the cosine of 5x minus 2x minus the cosine of 5x plus 2x. So I mean, these are kind of, as far as getting products to sums and vice versa, this is one of the nicer, easier sections in trig students like. So you'll get 1/2 times the cosine of 7x minus, or I'm sorry, the cosine, see, look at me if I'm not careful here. 5x minus 2x is 3x. I was looking over here. Minus the cosine of 7x. Now remember, you cannot combine these together and say, like, that's the cosine of minus 4x. These are angles. Never mess with the angles here. So these are like non-like terms in algebra. Do not try to combine them, and that is all that they are after in that first example. So we have taken the product and written it as a sum. All right, for example 2, we're going to do one more of these, and I'm going to show you where to be careful here. So this one, I'll write it right under the formula here. It says take the cosine of x times the cosine of some angle 7x and rewrite it as a sum or a difference. All right, so we're just going to go ahead for alpha, put in x, beta, put in 7x here. So we're going to put 1/2 times the cosine. Watch your notation here when you put this in and show it exactly like it looks here. And you'll stay out of a lot of trouble doing that. So we're just substituting in x for alpha, 7x for beta. And that's going to give us 1/2 times the cosine of negative 6x. Now we've got a negative angle here, plus the cosine of 8x. Now, whenever you have a negative angle, you have to go back to your identities again, and these are the ones I kind of stress more than any other. Remember, the cosine of some negative angle u is equal to the cosine of that angle. So I think on this one, we're going to have to use this identity and put in this answer, because they are not going to like that negative angle in there. So we will have for the final answer, this product, x times 7x is going to equal 1/2 times the cosine of 6x plus the cosine of 8x here. So be careful on these. Negative angle. Now what if that was a sine there? What if that was the sine of negative 6x? Now remember, the sine, you have to change the sign on one like that. So you may see that involved in this assignment as well. And you have to kind of go back. Your even, odd, or negative angle identities may come into play in this section. Okay, example 3, it says using the sum to product formulas here, we want to take this sum, the sine of some angle 7x plus the sine of 3x, and write it as a product here. So again, I've kind of got it lined up here. We're just going to put in 7x for alpha and 3x for beta, and we're just going to rewrite this as 2 times the sine of 7x plus 3x all over 2, and then be careful in here, simplification and so forth, times the cosine of 7x minus 3x over 2. So this will give us a final answer on this one of 2 times the sine, this would be 10x over 2 would be 5x, times the cosine, this would be 4x over 2 would be 2x. So we can go from sum to product, product to sum in this section, and we will show you with some angles how that will be affected as well. All right, example 4, one more of these where we're taking the sum and rewriting it as a product. Let's take the cosine of 3x plus the cosine of 2x here. So just make sure that you're getting these formulas lined up and you're substituting things well. So this would equal 2 times the cosine of 3x plus 2x over 2 times the cosine of 3x minus 2x over 2. So that would give us, for a final answer, 2 times the cosine of 5x over 2 times the cosine of x over 2. So that is how that one would work. And then we will move on here. All right, so for our last example here in the product to sum and sum to product formulas, it just wouldn't be good if we didn't put in an example that was a verification problem to show you how much nicer that you can rewrite things when it comes to it. I mean, look at all of these sums and differences here. All of this will verify to just be the tangent of that angle. And we're just going to use these formulas here for the difference, cosine u minus cosine v for the numerator and sine u sine v for the denominator. So let's just go ahead and verify this real quick and show you how much nicer life can be. All right, so for the numerator here, the cosine of 3x minus the cosine of 5x, I'll just put this over here for reference. I'm just putting in 3x for u and 5x for v. So on these vicious verification problems, don't panic, watch what happens. You're going to get negative 2 times the sine of u plus v over 2. So I'm going to put 3x plus 5x over 2. And then the sine of 3x minus 5x over 2. Okay, so I am just putting this in the numerator here. And all over, you've got the sine of 3x plus the sine of 5x. So in the sum formula here, I'm going to write this as a product. I'm just going to go ahead and put 3x in for u and 5x in for v. So this will give us 2 times the sine of u plus v would be 3x plus 5x over 2. And then times, this would be the cosine of 3x minus 5x over 2. So that will equal 2 times the sine in the numerator here, and that's a negative here, don't lose that sign, and you'll get 8x over 2 would be 4x times the sine, this would be negative 2x over 2, so you would get the sine of a negative angle here. Ooh, I'm starting to think even, odd identities, negative angle identities. What did I tell you earlier? What did I tell you? It would play a role. Equals 2 times the sine of, this would be 8x over 2, would be 4x, and this would be the cosine of negative 2x over 2 would be negative x. Oh, look at this, both of them in one problem. Young, how do you do it? How do you do it? So remember that the sine of minus x is equal to negative times the sine of x. So you have a negative times a negative out here. So you could rewrite this as 2 times the sine of 4x times the sine of x. So this negative angle becomes positive. That sign changes. The old even odd and negative times negative is positive all over 2. Now, what happens with the cosine of a negative angle x? Oh, these identities, make sure that you know them and know them well. Stays the same. The cosine of the negative angle equals the cosine of the angle itself. What reduces the twos? Anything divided by itself. 1. The sines, anything divided by itself. 1. We are left with sine x over cosine x, ladies and gentlemen. I say is tangent x. So what would you rather deal with if you were in a complex class, all of this or just tan x? All right, I rest my case for some of these formulas we've been talking about. So work on these product to sum to product formulas. Keep working hard on your formulas in this chapter. Bob Young signing off. Bye. You know, before I sign off here, I think I want to just show you something besides all of these manipulations we have used in this chapter. I mean, with all of our trig angle formulas that we've been talking about, it might be time to step back and just show you how these work with angles. I mean, we've been doing so many manipulations and so forth. Let's just take something. I want to show you something real quick before I sign off. All right, we could take one of these product to sum formulas here, and I think I am going to take this first one real quick here. And let's just put in an angle measure for U and V. I haven't shown y'all enough of this, I don't think. I mean, we verified them, we showed that they work, but let's put in some angles we know and practice our unit circle for a second. Let's take the sine of 90 degrees times the sine of, let's say, 60. I'll put that in here. Now, according to this first formula, this should equal 1/2 times the cosine of 90 minus 60 would be the cosine of 30 degrees minus the cosine of 90 plus 60 would be 150 degrees. All right, if these formulas hold here, so let's see if they do. All right, so the sine of 90 unit circle 1. The sine of 60 degrees would be the square root of 3 over 2. So 1 times the square root of 3 over 2, of course, is the square root of 3 over 2. Is that equal to, it better be, over this right side, this would be 1/2 times the cosine of 30 would be the square root of 3 over 2 minus the cosine of 150 would be minus square root of 3 over 2. So you could amaze your friends at parties. You can take any two angles, radians, degrees, put them in these formulas, ladies and gentlemen, and you will get 1/2 times, remember subtracting a negative means add, you would get 2 times the square root of 3 over 2, which the 2's would reduce to 1, and you would get, voila, the square root of 3 over 2. And this would work with any of the formulas that we've done. So we can go back here and so we can go back to the power reducing formulas, sum and difference formulas, double angle, half angle, you name it. So I'll take one of the power reducing formulas. Remember, those were the ones that were real long when we were showing taking these to a higher power and breaking them down to a single power. I mean, some of those for students are nightmares, but look how nice this is. Let's put 30 degrees in here for theta, the top one. We'll say the sine square of 30 degrees, according to this, and it will because we have verified them and stuff, is 1 minus 2 times 30 degrees. So again, you could amaze your friends at parties and so forth. Well, if you write the formula right here. Um, 1 minus the cosine of 2 times 30 degrees. I'm sorry, get out of here. All over 2. You have to make sure you just plug 30 degrees or whatever angle in these. So just having a little fun here. So the sine of 30 degrees is 1/2. If you square that, you will get 1/4. And then the cosine here of this would be 2 times 30. So this would be 1 minus the cosine of 60 degrees over 2 would equal 1 minus the cosine of 60 is 1/2 over 2. So I know you guys love fractions. 1 minus a half would be a half divided by 2 would be again 1/4. So you can put these in, ladies and gentlemen, into any of these creatures here. All right, and again, I'll do one with sum and difference identity. So I'll take the cosine of alpha minus beta here, and let's put in the cosine of, let's put in 3 pi over 2 minus beta is pi. All right, so on the left side here, so we'll show that this is going to equal the cosine of 3 pi over 2 times the cosine of pi plus the sine of 3 pi over 2 times the sine of pi. So again, any angle, radians, degrees, I mean, these are angles, so you'll get the cosine of 3 pi over 2 minus pi is the cosine of pi over 2, which is 0 on the unit circle, and you can practice your angles you know and love here. So let's see if this matches up. The cosine of 3 pi over 2 would be 0 times the cosine of pi is -1, so that would 0 out, plus the sine of 3 pi over 2 is going to be -1 times the sine of pi would be 0. That's going to 0 out. So again, you can put angles in here. It will work for all angles, radians, degrees. So now I feel better about signing off that we did that just instead of manipulation, showing you that that would indeed work. All right, Bob Young signing off. I promise this time. Bye.